Welcome students. In this video, we will be discussing about implementation of deleting a node from linked list. So before this video, we just have completed the iterative method concept as well as the recursive method also. Now we're going to take both the snippets, going to implement it here and going to verify whether whatever we have learned so far is right or wrong. Let us start. So first of all, we already have both the codes for for iterative approach on the left side you have, and for the recursive approach on the right side we have the code. And now we'll just going to implement both these codes now, right? So let me come here to editor. First of all, before implementing deletion process, we want to create a node first of all, right? So before creating a node, we want the header file as include stdlib.h, and also I want like struct node. I want struct node, and then followed by here inside the node structure we will be having a data member, and also we will be having struct node star next. Okay, struct node star next. Okay, now and also a semicolon. Fine. So we have taken the node structure and also stdlib.h. Now it is time for us to take create function which we already have. Like in all the other other implementation that we have done in linked list, we have a function called as create method. Yes, create function. So let us take a copy of this create function, and we will just paste it here and we will use it. And I think here, yes, so we will just use only display. Our display also we want to actually display the linked list. Okay, so we want also our display function also. So let me take our display function. Yes, it is here. So our display function, right? Our display function. Okay, fine. Sorry, I think we have just pasted it inside some function. Okay, but okay, fine. So our display function we have to, okay, before create method. Yeah, fine. So now we have structure, we have our display function, we have create function. With all this, now we can just start implementing delete node function. So the return type of the function is struct node star, because it is going to return either null or some address. So when we speak about null, address, something related to pointer, so we take the pointer return type, and then name of the function we will take it as delete node. We will take it as delete node, and arguments that is required. Arguments that are required is struct node star. Arguments that are required is struct node star. First of all, pointer p, and then struct node star pointer q, and also the position of the element which needs to be eliminated, deleted. Whenever we enter into a we enter into this function, the first thing that strikes my mind is that if first node have to be deleted, how to find whether first node is going to be deleted? Value of position. If position is equal to 1, if position is equal to 1, then it is first node. How to delete first node? How to delete first node? Right, that we will see now. First of all, we want the address of second node, because if first node gets deleted, second node will become the head node hereafter, first node. So the address of the second node is very important now, because we are going to delete first node. Address of second node is available in first node next pointer. So let us take a temporary pointer to store the address of second node, and the pointer is temp, and the address is going to be p of next, because p will be the first pointer. P will be having the address of the first node, because if position equal to 1, whatever P is having, that we will directly check, right? So initially we'll be passing the address of first node to pointer P. Okay, we took the address of second node and we placed it in the pointer, temporary pointer. Now it is time to delete first node, P node. P node is first node, right? P node. How to delete it? With the help of free function. Free is a function that is available in std.lib.h to delete or deallocate the memory allocated either using malloc or cloc. So free will be deleting a memory from heap memory. So free of, because while you use malloc, definitely memory will be created in heap memory. So free of, what we have to do? We have to mention the pointer name. So free of P. So address of the second node is stored temporarily. First node gets deallocated. And now we have to return the address of the second node. Because hereafter second node is the first node. So we need to inform. We need to inform that this is the address of the new first node. Okay. Then if not, else. If position is not equal to 1, then what we have to do? We have to move to a node. We have to move to a node having position, having that particular position. If position equal to 3, then we have to visit the node having position 3 to delete it. But we want two pointer. One pointer is going to store the address of previous node. One will be pointing to the present node. Initially, Q will be equal to null. P will be having the address of first pointer. So what I need to do, I need to take a variable called I, indicating that we are starting from first node, and we will be writing a while loop indicating that I less than position. So if the current node that you are visiting, it should be less than the node to be deleted. If both are equal, which means you found the node to be deleted, so you can stop. So if I is equal, I less than position, first thing is make Q point to P. Where whatever P pointing to the same node, let us also make Q to point. So Q equal to P will do that process. See, all these concepts already completed, only implementation. If you want to understand concept, go back to concept video. So Q equal to P. Now I also wanted P also move to next node. So P equal to P of next. Okay, fine. And also I should be incremented, because once you move to second node, you have to increase also I value, because I is telling us that which node we are currently in visiting. Okay, after this loop, this loop, pointer P will be pointing to the node that should be deleted. Q will be pointing to the previous node. Now, how to delete node P? After P, if there is any node, the address of that node should be connected to Q node. Already we made it very clear. So Q of next, we should be storing P of next. Okay, already, so automatically Q node is connected to the next node of P. Now only job is to delete the node P. So free of P. Node gets deleted. And finally, what we will be doing? We will be returning null, indicating that the first node is not changing. If any address is returned, then if any address is returned back, then the first node is changed. If null is returned, then the first node is not changed. Right? Fine. Now we will call this function here and we will check whether it is working properly. So after creating a linked list, let me create struct node star y at a pointer, and let me call the function delete node. What are the argument? First node, we will be passing address of first node for P. In terms of Q, we will be passing null, because there is no previous node for first node. So null node. And the position that we will be trying to delete is third node. And now we'll be checking the pointer y, and if that pointer is actually equal to null, then it means that first node has not changed. But if it is not equal to null, it is having some address, then the first node is changed. That first node is what? The address of y. So whatever address received from there, that we need to change. That will become the new first node. After which I will be calling the rDisplay function to display all the elements of the linked list, and I'll be passing the address of first node. Okay, let us check whether it is working properly or not. Terminal. Right, so it is gcc-o hello, and it is delete node ll.c. Any syntax error? No syntax error. Go for execution. Okay, I think we have not called create. Yeah, we have not called create method here, function here. It's not method, function. Okay, so create function. Fine. So now it is compilation, then again execution. So let us enter 23, 34, 45, 56, 67, 78, and also -1. So which node have to be deleted? Third node, which means 45. So after 34, 56 will be coming, 45 have to be deleted. Can you just check here? 23, 34, 45 missing, directly 56, which means that third node gets deleted successfully. It gets deleted successfully. So iterative approach of doing the same is fine. Okay, we have verified it. Now let us enter into the recursive way of doing the same procedure. So we will just start writing one more function, struct node star, and let it be the recursive delete node. It is recursive delete node. Okay, recursive delete node, and the arguments that we are going to pass here is struct node star p, then it is struct node star q, then it will be the third one, we will be taking I as the next parameter and int position as the next parameter. We already have discussed why four argument that we are taking. Coming into a recursive code, the first thing that strikes is the bounding condition. First bounding condition is if position equal to 1. If the first node have to be deleted, the same process we need to do, no changes at all. Okay, we will be doing the same process. Next one, else if sub, it is not else, it is else if position not equal to 0, so not equal to 1, then we will be checking I less than position. If I is less than position, what we need to do, we need to traverse the linked list up to a certain point. So if I is less than position, we are changing the value of q, and we are changing the value of p, and we are changing the value of I. These are the three things that we are changing. All these three things are argument. When you want to change the value of the argument, what should be done? You have to call the same function. You have to call the function, and you have to pass different values for the argument. So call the same function r delete node. What we are trying to change, instead of p, we are trying to change it to p of next. So instead of p, just please pass p of next. So the first argument will be p of next. What's the second argument? Q. By default, see, no, it's not okay. Q value should be, for example, it is like q value is changed to p. Whatever is p value is given to q. So instead of q, pass p, comma. I value is incremented by 1. So I plus 1. Position remains the same. Fine. This is if I less than position, this recursive call will do the process of the while loop as it is. The same Tito. Else, if this condition is also not true, what you have to do? You have to do the remaining process here. The same process you have to do here. Okay, you have to delete it. Okay, you have to delete, change the link, and this return null, let us have it outside this else, because if the first node is deleted, we will return the address of first node. If not, if in both these cases we can return null, which says that we are okay, which says that the first node is not getting deleted. Because when you have some return type, each and every block should have some return statement, meaning that suppose if I provide this return statement inside else, if this else if is true, then it is not having any return statement inside. Outside also no return statement. So Writing a function specifying return type but not using return statement is absolutely a wrong way of writing a function. Whenever you specify return type, definitely something should be written with the help of return statement. If not, it is considered as an error in many compilers, right? Fine. So shall we execute this and check? Yes. Instead of calling iterative method, let me call recursive method and check. One more argument is I value also we should include. That's it. Okay. So let us execute now and just check. Is it working properly? Is there any syntax error? No syntax error. We will go with execution 23, 56, 98, 12, 56. Okay, again 57 and then -1. So which node have to be deleted? Third one. 98 will be deleted. Yes, 98 is deleted. 23, 56, 98 deleted, then 12, 57. So recursive approach is also working. But let us try to delete the very first node also. So let us try to change the position 1. Again compile. And we'll go for execution. 23, 34, 45, 56, 67, 78. So which node have to be deleted? First one, 23 deleted. So linked list will start from 34. Yes. So it's working perfectly. So in this video, both the iterative as well as recursive approach of deleting a node from linked list have been completely done, successfully implemented. Right? In the next subsequent video, we will be discussing about time and space complexity analysis of both the methods. Okay, fine. Thank you, students.